Good evening to Sir Petrus Bintanati. We from Group 5 want to present about gas turbine in power plant. A gas turbine is a combustion engine at the heart of power plant that can convert natural gas or other liquid fuels to mechanical energy. How turbine works? The air-fuel mixture ignites. The gas turbine compresses the air and mixes it with the fuel, which is then burned at a very high temperatures, producing hot gas. Secondly, hot gas rotating turbine blades. A mixture of hot air and fuel moves through the blades in the turbine, causing it to rotate rapidly. Third, the rotating blade rotates the drive shaft. The fast rotating turbine blade rotates the turbine drive shaft. Fourth, the rotation of the turbine powers the generator. A rotating turbine is connected to a rod in a generator that rotates a large magnet surrounded by a coil of copper wire. Lastly, generator magnets cause electrons to move and produce electricity. The fast rotating generator magnet creates a strong magnetic field that lines electrons around the copper coil and causes it to move.
Hi, Assalamualaikum. My name is Muhammad Takiuddin Afiq bin Raham. My matrix number is 07 DKM19F1064. I want to discuss about the types of compressor. We have two types of compressor. It's first a positive displacement compressor and then dynamic compressor. In a positive compressor, we have divided into two names. First, reciprocal and rotational types, and then in dynamic compressor we have a centrifugal flow and axial flow. About the positive displacement is the positive displacement air compressor force air into the chamber where the volume is reduced to compress the air. Sometimes our positive displacement compressor are better equipped for industrial workloads. About the reciprocating air compressor, reciprocating air compressor is a type of positive displacement compressor that use piston. We have in this type piston compressor we have two types. First, a single stage and then two stage. First, in a single stage compressor, air is compressed on one side of the piston. And then about the two stage, compressor has two compression chambers on either side of the piston. About the rotating air compressor, which is the simplest compressor, consists of two rotors and rotating lobes in an airtight casing that has inlet and outlet ports. We discuss about the rotary vane. A rotating vane compressor is like a rotating screw compressor, but instead of a screw, the vane is mounted on a rotor and rotate things inside a cavity. Air compresses between the ram and its casing as in the push out of different exhaust ports. Next, about the rotary screw. Rotary screw is a compressor have two internal screw that rotate in opposite direction, trapping and compressor air between them. Both screw also generate constant movement as it rotates. This is a common types of air compressor and is the one of the easiest to maintain. Engines are usually industrial in size and grade for continuous R. Thank you.
Good evening, Sir Petrus. My name is Shazwan bin Abdul Hamid. Matrix number 07 DKM1NF 2059. Dynamic type of compressor. Dynamic displacement compressor uses rotating blades powered by an engine to generate airflow. The air is then confined to create pressure and kinetic energy is stored in the compressor. The air designed primarily for large projects such as petrochemical plant or steel manufacturing, so it's unlikely you'll be able to find them at your local mechanic. Just like a positive displacement compressor, there are two different types of dynamic displacement, axial and centrifugal. Axial compressor uses a series of turbine blades to generate air, pushing it through a small area. Although similar to other blade compressors, axial compressors operate with stationary blades that slow down airflow, increasing pressure. This type of air compressor is not very common and has limited functionality. It is used primarily in aircraft engines and in large air separator plants. A centrifugal blower compressor is a common type, having a rotor or impeller in which several types of curved vanes are arranged symmetrically. The rotor rotates in an airtight casing with in and out points. In this type of a compressor, the casing of the compressor is designed so that the kinetic energy of the air is converted to pressure energy before it leaves the casing, as shown in the figure. Mechanical energy is given to the rotor valve and the external source. Combustion chamber. The combustion chamber is the area inside the cylinder where the fuel and mixture is ignited. When the piston compresses the fuel and mixture and comes in contact with the ignition plug, the mixture is burned and pushed out of the combustion chamber in the form of energy. The cylinder houses many important components of the internal combustion engine, including the injector nozzle, piston, spark plug, combustion chamber, and others. It provides a confined space for the combustion of air and fuel mixture. It houses the inlet and outlet valve for incoming and outgoing of mixture. It houses and guides the piston. It helps in proper combustion by proper geometry. It withstands against the high temperature of combustion. It prevents the spill out of the exhaust of combustion.
Turbine. A turbine, meaning vortex, is a rotating mechanical device that extracts energy from a fluid flow and converts it into useful work. Working principle. Turbine is rotary mechanical device that extract the potential energy and kinetic energy of combination gas and convert into the mechanical energy. Functions. The spinning turbine drives a generator that converts the energy into electricity, produce a source of rotation to do a job. Process. High temperature pressurized gas enter a turbine, producing a shaft work output. In the process used to drive compressor and unused energy come out exhaust gas that can be proposed for external work. Advantage and disadvantage of gas turbine plant compared to other power plant. Advantage: very high power to weight ratio compared to reciprocating engines, can run on wide variety of fuels. Disadvantage: co-engine costs can be high due of use exotic material, less efficient than reciprocating engine at idle speed. Conclusion. In conclusion, we have gained various knowledge in carrying out his case studying. Among them are gas turbine power plants, related compressors as compressed combination chambers turbine, as well the advantage and disadvantage of gas turbine plants. With this is very beneficial and useful to use if we work or conduct industrial training at power plants in the future.